Have you ever stopped to wonder how your car actually thinks? Well, today we're going to pull back the curtain on the hidden nervous system that makes everything from the engine to your radio work together in perfect harmony.
So here's a wild fact for you. The car you drive every day has more than 50 computers inside it. Seriously, there's one for the engine, one for the brakes, one for the power windows. They're all little specialists. But how in the world do all these specialists talk to each other without getting their wires crossed? Well, that's the exact puzzle we're going to solve today.
So first up, the car's hidden brains. Let's get to know these tiny specialists that are running the whole show.
Okay, so each one of these little brains is called an ECU, which is short for Electronic Control Unit. The best way to think of an ECU is as a specialist with just one single job. You've got an engine specialist, a brake specialist, an airbag specialist. You get the picture. Each one is a total expert in its own little world. Now, before we had a smart way for them to talk, connecting all these ECUs was a massive problem. I mean, imagine trying to give every single employee in a huge office a direct private telephone line to every other employee. It would be a complete and total mess of wires, right? Well, that's exactly what was happening inside our cars. And as we started adding more and more features, things like power steering, electric windows, all kinds of advanced sensors, the wiring just became an absolute nightmare. A tangled, heavy, and really expensive web of copper. This didn't just make cars heavier and less fuel efficient. With so many connections, it also meant there were way more chances for something to go wrong.
So clearly, this tangled mess just wasn't sustainable. Engineers needed a much smarter way to do things. And that breakthrough came in the form of a simple yet brilliant network.
And this slide just perfectly illustrates the difference. On the left, you see the old way, a point-to-point disaster. And on the right, you see the solution, the CAN network. Instead of that crazy web, it's a clean, simple two-wire information highway that every single ECU can just plug into. It's really a stroke of genius in its simplicity.
So this new system is called CAN, which stands for Controller Area Network. You know, the best way I've found to explain it is to think of an old-school party line telephone. All the ECUs are on the same line, everybody can hear every conversation, but they're smart enough to only pay attention to the messages that are actually meant for them.
And here you can see it in action. You've got that one central highway, we call it the bus, and all the different ECUs, or nodes, are just connected right to it. The engine, the brakes, the transmission, they're all on the same road, sharing information back and forth. But wait a minute, if everyone is sharing the same highway, how do you avoid massive traffic jams and collisions? Well, you need rules. So let's take a look at the rules of the road for the CAN network. Here's the first key rule. And it's a bit counterintuitive. An ECU doesn't send a message to a specific ECU. Nope. Instead, it broadcasts its message to everyone on the network. It's kind of like shouting an announcement in a crowded room for everyone to hear. So how does the right ECU know which messages to actually pay attention to? Well, every single message has a subject line, which we call an ID. This ID tells everyone what the message is about, like wheel speed or engine temperature. Then the message also has the actual data, like 60 miles per hour. ECUs are programmed to only care about certain subjects. The airbag ECU, for instance, is always listening for crash data, but it really couldn't care less about what radio station you're listening to. Okay, but this brings up a really critical question. What happens if two ECUs try to talk at the exact same time? You'd think that would cause a data collision, right? But the CAN network has an incredibly clever way of handling this. And the solution is this beautifully simple principle. The most important message always wins. This process is called arbitration. It's basically a competition that ensures the most critical information is never, ever delayed. So the best way to explain arbitration is with an analogy. Imagine your radio's ECU wants to send a message to change the volume. At the exact same time, the ABS brake controller needs to send an urgent message because your wheels are locking up. Well, the brake message's ID has a higher priority. Think of it like an ambulance with its sirens blaring. The network is designed so that the lower priority message from the radio immediately stops talking and waits, letting that critical ambulance message get through without any delay. It's brilliant. On the CAN network, safety always gets the right of way. Now, on top of being really smart, the CAN network is also incredibly reliable. Every ECU is constantly checking every message it hears for errors. If a message gets even slightly garbled, it's immediately flagged, and the sender automatically tries again. This built-in error checking is exactly why we trust CAN for life or death systems, like our brakes and airbags. Okay, so we've got our physical highway and the rules of the road. But how do all the different software programs in the car actually use this highway in a consistent, standardized way? Well, that's where a software rulebook comes in, and it's called AutoSAR.
Now, don't worry about all the different boxes on this diagram. The only thing you really need to see is that the CAN hardware, the physical network, is at the very bottom, and AutoSAR is just a set of software layers built right on top of it. It's kind of like a universal translator that allows all the car's applications to use the CAN network without needing to know all the nitty-gritty hardware details. This is the key takeaway right here. If the CAN network is the physical road, then AutoSAR is like the set of traffic laws and road signs that all the software drivers agree to follow. It makes sure that all the different software components from all the different car makers can drive on the same road safely and predictably.
So, just to be perfectly clear, AutoSAR does not replace CAN. Not at all. It's a software standard that works with CAN. It's the common language that allows software from dozens of different suppliers to all speak to each other over that one CAN network.
All right, let's just recap the key ideas from today. Number one, the CAN network replaced a tangled mess of wires with a simple two-wire information highway. Two, its priority system makes sure that the most important messages, like for your brakes, always get through first. Three, it's incredibly reliable because it's always checking for errors. And finally, four, AutoSAR provides the software rulebook so all the different programs can use this network together.
So, this really elegant solution, which was born inside the automotive world, now runs everything from factory robots to life-saving medical equipment. Now that you understand your car's hidden nervous system, it kind of makes you wonder, what other invisible networks are out there, quietly running the world all around us?